Hello everyone, today we are continuing with day 4 of Advent of Code 2023. We're back to using GPT-4. I did a little bit a trial of Gemini Pro, and actually was impressive. I was able to solve one of the previous challenges we did, one that GPT-4 wasn't able, but however in my further tries didn't perform any better than GPT-4. Wasn't able to do some other challenges and some that GPT-4 couldn't do, and today I will go back to GPT-4. But roughly to see the challenge, we're exiting our gondola. We're looking for something, and okay, I will let you borrowing my boat and you can go visit the gardener. I got all these scratch cards are these like cards that you can win a big reward as a gift, but I can't figure it out what I've won. Okay, we need to help the elf to figure it out what's his scratch cards reward. The elf leads you over to the pile of cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. Picking one up, it looks like each card has two lists of numbers, okay, separated by a vertical bar. A list of winning numbers and then a list of numbers you have. You organize the information into a table, your puzzle input. As far as the elf has been able to figure it out, you have to figure it out which of the numbers you have appears in the list of winning numbers. The first match make the card worth 1 point. In each match after that, the first doubles. Okay, which means here I have my winning numbers, and here are numbers which I have, and I need to see how many of this number actually correspond to number here. And if I have one of them, I will have 1 point. If I have 2, will be 2. If I have 3, will be 2 multiplied by 2, 4, and so on. It seems like the numbers of winning cards will be a power of 2 n minus 1, because if I have only one winning number, I will have only 1 point, which is make 1 minus 1, 2 to the power of 0, it's equal to 1. Okay, and that is how we can calculate the point for each card, and after that we need to simply sum up them probably. Is that what we need? So yeah, we need to sum them up. Here it's simply telling us we have 5 cards, we have 4 matches, etc., and which one how much they are. Okay, that looks pretty straightforward. Let's go from here, don't need the other part, and simply ask write me a Golang program that solves the task given in triple backticks, the program should its input from a file path, therefore input text. In here we have the task. Let me see how we'll do. Actually expect this to be relatively easy to handle. We have day 4. We have here input text. We have part 1. Go and let's see. How our program works. Okay, that seems reasonable. We're splitting with empty space, convert to integer, works fine. Calculate the points, it's point multiplied by 2, it's actually perfect. And range wise. Okay, and we are adding the total to each of them. And if there is nothing, we're returning 0. Okay, beautiful. And that looks very right to me. We are getting 25,000. And that works out of the box, which is what I would expect. Let's see what's changing for part 2. Part 2, just as you're about to report your friends to Delph, one of you realized that the rules have actually been printed on the back of every card this whole time. There is no such thing as a point. Instead, scratch card only causes you to win more scratch card equal to the number of winning numbers you have. Specifically, you win copies of the scratch cards below the win card equal to the number of matches. So if a card 10 were to have 5 matches, numbers you will win 1 copy of each card. 11, 12, 13, 14 and 15. Copies of scratch cards are correct like normal scratch cards and have same card number as the card they copied. So if you win a copy of a card 10 and it has 5 matching numbers, you would then win a copy of the same cards that originally card 10 won. This process repeats until none of the copies cause you to win any more cards. Cards will never make you copy of a card past the end of the table. Okay, now I have the matches. It has 4 matches, so you win 1 copy each of the next 4 cards. Card 2, 3, 4 and 5. Your original card 2 has 2 matches numbers, so you win 1 copy of each card 3 and 4. And copy of each card. There are 14. And now I'm calculating for all of these copies. Okay, interesting. Okay, let's give a try with the second part. Dang it. Let me okay. Not good, not good. Yeah, let's see how we'll do in the second part. Okay, now we need to do first pass in which we count actually the cards converting twice. Okay, interesting. Winning numbers, your numbers. Okay, interesting. Okay, here we have this logic for the matches. Look, interesting and about right. Because beyond the first card and so on. Actually it looks about correct. Yeah, let's see if no, but okay, that's how many scratch cards I want. I will have 300, 6, 7, 8. Okay, that's not correct. Okay, let's see if we start from scratch. Okay, now it has copies, your numbers, winning numbers. Twice. Yeah, let's see if this structure that's keeping out this information will do better than the previous attempt. No, I think this okay. Yeah, let's see. Okay, now it's keeping empty ones. Okay, interesting. So far so good. I do in 64? Simply everywhere. Then 64. Is it something? So no. In 64. Let's see if I can use in 64. Okay, that makes sense. Still getting negative number. Okay, let me do short pause and see how it goes. Let's see what's 64. Did it change something? Not really. Let's say that we have potential overflow. And let's see, this one, the other approach was like couple hooks. Simply completely wrong. Oh my god. Yeah. Okay, but how to have I'm getting a number okay, interesting. Does this make sense? Okay, it doesn't seem working. Let's try it. Art. Right. Yeah. Given triple backticks. No. Should read its input from a part, therefore input text. Nice. Okay. is there a way? Yeah. Okay, let's see what this begins. This will work. If not, yeah, let's see what that might begin. Okay, it seems to work, but no, that's not a solution on my task. Okay, but it's yeah, let's send to them and see. Begin. Okay, but it's simply, yeah, very useless. Let me run it multiple times and see if I'm getting the same answer. Yeah, I'm getting the same answer. Is it, should it be some logical wrong? Now it's starting from the next one and the cards. Yeah, I mean, this seems about right. I think it might be. No, it didn't change anything. I'll do it with the test example. See if we'll work with the test one. Test, text. We have this one, and I can't here say instead test. Okay. Again, let's open a brand new. Let me go on. As given in triple backticks. The program should read its input file with path day for test text. Okay, let's see. Now it has illustration of example and so on. Parse the data, process the card. Okay, let's see how does do it this one. Yeah, let me do the phone. Of 30 was what I would expect. Yeah. Okay, let's see. Unfortunately, the hook more or less the same. Yeah, let's see. Let me finish this. Let's see. No, okay. This one never stops. Let's see one of the test example. It's completely wrong. Okay, let me see. Both are quite battery. Yeah. Okay, let's see. I think this will simply not work. It's not compile. Yeah, let's see. But okay, that looks a little bit more promising than this one. Okay, that's again failure. And says that I'm getting scratch cards. Yeah. Okay, let's see. completely wrong. So be right for the big one. Yeah, it didn't work. Correct. Okay, I can see more and more attempts. To do it, but falling short. Or this is the same. I didn't see much difference. Okay, let's keep that like a last attempt. Yeah. I mean, not that any of them it. It's strange that fell apart. That is punching. Yeah. Yeah, we'll assume that we need a lot of work before to get to AGI. We fell again on day 14. On day 14. On day 4, the second part, we did that on day 3, part 2 as well. And even on day 1, part 2, we were able to solve it with Gemini Pro, but initially GPT-4 wasn't able to do it. It so far looks very far away as a really robust programmer that can solve complicated challenges, albeit this one it's not very simple, but it's again not extremely hard as well, and we are talking for 218 cards. Interesting to see how we'll be with a new version of the program. Yeah, still wanted to try to see if simply adding the number of cards will somewhat help, and the fact that never either the old or the new system are doing this skipping not very encouraging. That should be something that the program should be able to do by default, but yeah, nevertheless. Okay, 4 seconds, almost there. See that will not make it pass. Okay, we confirm what we already expect, and hopefully let's see how it's going on some of the future challenges. Thank you for your time and hope that was somewhat useful.